Hello, I'm Rex Vokey, KE6MT, and this is HF on a Budget. A little about me. I've been a ham since 2015. I've always loved tinkering with electronics, and actually, for that matter, tinkering with anything. I got into ham radio because I wanted to replace a FRS radio I had, and got a Baofeng radio, I think, off of Amazon, and found out that I'd need a license to use it. I also found out I had thought you needed to pass a Morse code test in order to get into ham radio, and found out that wasn't the case. So I went ahead and jumped right in and got my license back in 2015, and the rest is history, so they say. I'm a runner and hiker and lots of other things, so I tend to operate mostly portable when I can. I do have a home station, but I like to do summits on the air whenever I get a chance. I'm also the California region or California Association manager for Summits on the Air. So, why do HF on a budget? Well, I'm going to tell you information I really, really wish I had when I was a new ham. Because HF intrigued me, but it just seemed totally out of my reach and too expensive at the time. You know, I didn't want to dump a bunch of money into this new hobby, but at the same time, I was really interested in what I could do. I tried, various simple CW kits, and I can tell you, don't go buy a Pixie or a Rockmite if off of eBay, if you're looking into trying to do things on the cheap. It's just going to be too difficult. You may learn some things along the way, but here's some information that will help get you in without kind of missing the mark, so to speak. So right now, the way I see it, we have a new golden age in amateur radio. From the hardware side of things, we have tremendous access to information. And actually, even from the perspective of just getting your license, there's so many resources now. YouTube videos, lots of different YouTube channels, building things. There's tons and tons of information. There's great availability of parts. There's parts that do lots of things. So you're not necessarily having to come up with all the discrete parts to build something. There's super well-designed kits, especially from Hans Summers at QRP Labs, and we'll get into that a bit. And microcontrollers, this kind of goes into the parts thing. They can provide a lot of functionality that you can program into something. And there's even ways you can make a microcontroller transmit HF frequencies if you filter it properly. So lots of things coming together to make this what I see as a golden age in amateur radio. And the magic of shortwave or HF radio is you can do beyond line of sight communications. I did a little drawing on the slide here. You can see these two stations are basically down in valleys between a mountain, and as you can see, line of sight's just going to hit this mountain and go nowhere. Even if these stations are 2 miles apart, they're probably not going to hear each other. However, with HF, it's a little bit of a different problem. If you're too close, you may not hear each other. But the general idea is you can make this path, this ionospheric path, bouncing off the ionosphere to this other station over hundreds or thousands of miles, sometimes all the way around Earth. And low power QRP can work. It's not necessarily going to get you as far, but it can really work, especially if you're using CW or Morse code. There's a wide array of antenna possibilities and a lot of flexibility in how you do the antenna. So if your measurement's an inch or two off, you're probably not going to be heavily penalized on HF, whereas with a VHF antenna, you're going to have big big problems potentially. And last but not least, we're getting into solar cycle 25, so the level of success you're going to have making contacts through the ionosphere is going to be increasingly better over the next several years. So how do we do this on a budget? Well, you've got to be willing to invest time. You know, it's as often the case with a lot of things. You've got to be either willing to put in money or time, or both. But in this case, you'll need to put in a little bit of money and probably a lot more time than you would have to if you just went and bought an off-the-shelf radio. It does help to have some electronics familiarity. If you've taken things apart before, put things together, soldered anything, all of these things can help. It's not absolutely critical because these kits really introduce you pretty smoothly to getting into assembly of the kits, but some familiarity can help. It's going to take persistence because inevitably you will run into things that slow you down or stop you, and you're going to have to work through that. Sometimes those things are small, sometimes they're a little bit more difficult to deal with. And patience, of course. You don't want to rush through this. You don't want to, you know, skip over some part of the directions and install something backwards or some other thing. But you want to really be patient working through this. So those are your costs. You need to be willing to invest that time and keep working through it. So what's needed? This is the hardware end of things. You're going to need some basic electronics tools, a transceiver, of course. An antenna will really help you. You got to be able to get those radio waves out into the air. A key or paddle, so you could use a straight key or a paddle depending on what you want to do. I recommend a paddle. An antenna analyzer is going to help you build your antenna, and they're not crazy expensive anymore. There are inexpensive options. Wire and cables, of course, you're going to need various wire and cables. And you got to have some way to power the transceiver and some way to hold your antenna up. So that's antenna support. Let's get into this in a little bit more detail. So for the basic electronics tools, you're going to need a soldering iron for sure. It doesn't have to be a fancy one, but a quality one can help, although even if you go with the most basic one, you'll still be able to get the job done. Screwdrivers, you're going to need various Phillips and flathead screwdrivers from sometimes Phillips size 0 all the way up to 2. A multimeter is very handy for building this stuff. Even just something that can check continuity and resistance, and voltage is also handy. But as you'll see later in the presentation, the QCX actually has some test equipment built in, so there are some ways to get around some of this, but a lot of these things are handy to have. Diagonal cutters are a must-have. You got to be able to cut the leads on the components after you've soldered them. Needle nose pliers are probably the most handy type of pliers there are, so you should probably just have these for life. And helping hands, they help, you know, I don't know if you've seen these, but they're the two little alligator clip type things mounted on a little base, so you can hold things in place while you're working on them. A magnifying glass is handy, especially if you're like me and you're starting to use reading glasses to see things up close. This isn't an absolutely critical thing, but it's a really handy one to have. And a big hammer in case everything goes wrong. No, you don't really need that, but who knows? Sometimes it comes in handy. So for the transceiver, I'm recommending QRP Labs QCX Mini. This is by Hans Summers. He's an absolute genius in designing these radios. There was the original QCX, and I have a whole blog post on doing HF on a budget with that from back in, I think I wrote it back in 2018. That one's not currently being made, but there's the QCX Plus, which is a bigger version of the original QCX. And then there's the QCX Mini, which just recently came out, and that's actually a little bit harder to get. So if you order it, you'll have to wait a while to get it. But these kits are exceptionally well thought out, and the instructions for putting them together are so detailed and so helpful that if you just follow the instructions step by step, you're going to end up with something that works. You do have to follow the instructions carefully, but it's very straightforward. These kits are through-hole kits, so the components that you're soldering, the leads go through the board and you solder them. There's no surface mount soldering to do on these kits. This QCX Mini kit, it actually comes with all of the surface mount components already soldered. So you just take your magnifying glass and go over those connections, make sure nothing looks horribly wrong. It's a low-cost kit. It's $55 or $80 with the case. As you can see, having the case is pretty nice. It fits in there super snugly and allows you to take it into the outdoors and wherever you might want to take it and protect all the sensitive electronics inside there. So yeah, I can't recommend this kit enough. But this is a transceiver. By the way, it's a single band. So the one in the picture is for 30 meters or the 10 megahertz band. If I were to have just one, I would probably get a 40 meter or 7 megahertz band. And that's actually what I did for the original QCX. So if I were to just build one, or if I maybe had a technician license and I want to operate Morse code, I would get the 40 meter version most likely. So, antenna. I'm recommending specifically the QRP Guys NFED half-wave. It's called the No Tune NFED. Let's see, we have the whole name here. The QRP Guys No Tune NFED half-wave antenna. It's a mouthful. This antenna is super easy to put together. You wind this transformer, you solder this capacitor and the transformer into this board, you solder the connector on, and you cut your wire to the recommended length. This is where the antenna analyzer comes in handy. You'll want to cut the wire to the length you need for the band you're doing, and use your antenna analyzer to get it into the range you want to use it for the radio. It's very easy to put together. The only thing I don't like about this kit, and I have these two pictures here to illustrate this, is this winder is designed to wrap the wire around in a circle around the length of the board here in this narrower spot. That doesn't work very well when you're trying to deploy the antenna. It twists the wire, and so you have to carefully unspool it as you're taking the wire off this thing. What's better is a kite winder, and by the way, these two things are about the same size. This may look bigger, but it's actually pretty small. With this, you're able to do a figure-8 wind, which does not twist the wire and allows you to just hold this part of the winder and pull, and it unspools itself as you walk along. So I like to wind the wire on here. I may modify this to cut out this section here and make it more of a shape like this on this kite winder, and try winding the wire that way with the figure-8 wind. But this kit is very good. It's $20 and it'll get you your antenna. And NFED half-wave antenna is essentially just as effective as a dipole antenna when you're trying to get your signals out there. So I like it. So for a paddle, there are countless options available. You can build your own, you can buy them, you can spend hundreds of dollars on a paddle or a key. especially those nice Bengali paddles. But for this budget option, there are various 3D printed designs out there. So if you have a 3D printer, you could print your own and put it together. I do not have a 3D printer, so I searched for a paddle I could just buy, and I found this one on Etsy. The call sign is escaping me at the moment, but there's a guy on Etsy that sells these, and you can just search for Morse code paddle or CW paddle on Etsy, and you should be able to find it. There's also similar options available on eBay. This is a double paddle design. I actually prefer a single, but I wasn't able to find one quickly to put together with this kit, so I got a double. It really comes down to preference, and you just want to get what works for you. Straight key is an option, but I would say if you're just learning and you're going to go through learning CW and practicing CW, having and using a keyer like the one that's built into the QCX and using a paddle with it like this can be a good way to go. That's the way I learned. The antenna analyzer. So the Nano VNA is this, over the last few years, this has come to be more and more popular, but it is a open sourced vector network analyzer, and you can use this as an antenna analyzer. There are a lot of videos out there on how to use it, a lot of blog posts on how to use it, but it costs for this model between $43 and $55 roughly. There's a model with a bigger screen that's a bit more. I think it can get up to $100, but still, for something that does as much as this thing can do, insanely cheap. And it works really well. I've put together many antennas with this. I've designed and built antenna traps with it. So it's a really, really great tool. I'm realizing now that I should have had the screen on in this picture, but yeah, it's a very useful tool. This will get you going, building your antennas. It'll really speed things up getting your antenna built. And then wires and cables and other items. So in order to get your antenna built and get things hooked up, you're going to need different things to connect things, like connect your antenna matching unit to the radio, that sort of thing. So you'll need potentially, and you kind of have to feel your way out on this, but short coax cables with BNC connectors on them, different BNC adapters, or maybe some other adapters. That antenna that I pictured there, the NFET half wave, I actually use a super short coax cable with BNC connectors, or I even just use a male-to-male barrel connector and connect it straight to the radio. A dummy load is something that will be really, really handy to have. When you're building your radio, you can test it without having to hook it up to an antenna. You don't want to have it hooked up to nothing. You can get a dummy load from QRP guys or QRP Labs, eBay. There's a lot of different places. Just search for QRP dummy load. Antenna wire, you're going to need that in order to build your antenna. Just about any wire will do, but in this case, probably the lighter the better. It's easier to work with. And then headphones and a paddle cable. So headphones, just about anything will work. A paddle cable is just a stereo 2.5 millimeter to 2.5, not 2.5, 3.5 millimeter to 3.5 millimeter connector. So just about anything will work with that. And then I've listed out a few places you can search for this stuff. The Wireman, Pactena, Cables Online, eBay. There's also Amateur Radio Supplies I didn't list on here. They have a lot of different things. And for power, I'm recommending this specifically because it kind of does everything you'd need it to do. If you search on Amazon for Talent Cell 12 volts, they have a lot of different options. even the smallest one will work. These battery packs, they're lithium battery packs that put out 12 volts and also have a USB output. So it'll power the radio quite nicely. But there's tons and tons of other options out there. Basically, if you can get anything that, for the QCX, if you get something that can provide up to 1 amp, the QCX won't quite draw that much, but if you get something that can provide up to 1 amp and between 11 and 14 volts, you're good to go. Battery options do include lithium polymer, lithium iron phosphate. That's one of my favorites because they're very forgiving in how you treat them. They are a little heavier than lithium polymer, which can be dangerous if you don't have protection circuitry for them. And then there's SLA, or sealed lead acid. Those are the heavy lead-based batteries you can find in alarms and UPS units and that sort of thing. Those are probably my least favorite because in the long run they can actually cost you more with the number of cycles they give you, and also their rated capacity is, you can't use all of it. So definitely lithium based are one of the best you can go with, and these talent cell packs, they're great. I've used it quite a bit, so good thing to go with. And antenna support. There are a lot of different ways you can support your antenna, but my favorite by far are these cheap fiberglass poles off of eBay. They are telescopic fishing poles. I search whenever I need to buy one. I search for FRP 7.2 meters on eBay. They're getting kind of hard to find right now. I think there's some fluctuation in their availability, but they're not actually 7.2 meters. They're more like, I'd say 5.6 roughly. I think they include the length of all the individual sections, not the total extended length. It's kind of a funny thing. Anyway, they get the antenna wire up there high enough. As you can see here, this is my end-fed half-wave antenna on a Summit, and you can see the wire going up to the top here, or near the top, and then back down. I have a little ice cream lid plastic that I cut out, and I drill a few holes in, and I just slide that over the top of the antenna pole. These fiberglass poles are under $30. I've been able to get them as low as, say, $12, but right now it's they're a little pricier than that. You don't have to use one of these poles, but you can do things like throw your antenna wire over a tree branch. I've done that a lot. There's definitely other extendable poles you can use to get your antenna up there. So that's how you get your wire up in the air. So how is all of this done? So we talked about the equipment, but what do you actually need to do? So with the equipment, it's good to set up a place to do the assembly that's not going to get disturbed, because some of the assembly could take over several days, or it could span several days. So you don't want to be doing this necessarily on the table that your family eats dinner on every night. So set up a place that won't get disturbed. Get your tools if you don't already have them, and build the radio first. You're going to learn a lot from this kit, from the QRP Labs QCX. It's going to teach you a lot, and it's a great journey. It's also just, the instructions are so great, and it tells you what you need to build it. It's just a really great place to start. And it'll also allow you to start practicing Morse code. So the QCX has a practice mode where it won't transmit or anything, so you could plug a paddle in or whatever you improvise as a paddle and start practicing your Morse code. And then, this is a big one, learn CW, or Morse code. The way I finally did this, I did a lot. There's lots and lots of different tools, and you can just Google this or whatever search engine you like using, but you can look up what you need to do to learn Morse code. But I separated this point over here as a special kind of thing, because you can get into QRP radios because they're inexpensive and all of that, but with voice, you you're going to have a little bit of trouble getting out there sometimes with your voice at 5 watts or even 10 watts. With Morse code, you're getting a free kind of boost just by using CW or Morse code. Your 5 watts that you're putting out from your QCX, or 4 watts or whatever it ends up being when you finish building it, that 5 watts is like 80 watts on voice. So you're getting a free power boost essentially because of the efficiency of the signal coming out of CW or Morse code. The way, after using lots and lots of different tools, the way I finally got really up to speed on CW or Morse code is to sign up for CW Ops CW Academy. There can be a bit of a waiting list for the first level of classes for this, but they're always trying to add instructors, and I may sign up to be one someday. We'll see. But sign up for CW Academy, and that'll get you up to speed. The accountability is really what helped me. Not having to force myself to do the practice every day, or rather having the expectation that I need to do it. Because they have meetings, I think, twice a week. It's been a little while since I did this now, but you're assigned homework in between those meetings and you're expected to practice every day. So having that expectation really got me up to speed. There's also Long Island CW Club that I've heard good things about. I haven't signed up for their club yet. I do plan on doing it just to keep improving my Morse code. But I've heard there are a lot of good classes, meetings, and help you can get with Long Island CW Club. I've heard great things about it. Practice every day if possible, but practice in small 15-minute chunks of practice, or less than 15 minutes. But that practice, that constant practice is very important, but you also don't want to burn yourself out by going for half an hour or an hour straight of listening to Morse code. I'm not saying you don't do that, but just keep an eye on really burning out on it. I did find that for me, about 15 minutes straight of listening to Morse code was about the limit. And then it can't be stressed enough that to get good with Morse code, you have to listen. Learning to send Morse code is pretty easy compared to receiving it. So just constantly practice listening and get good at it that way. And just to cap this all off, if you're a technician and you're just getting into ham radio, you have a technician license, keep in mind these squiggly areas here, you can get into HF as a technician with Morse code. So 80 meters, 40 meters, and 15 meters, you can actually get into HF as a technician using Morse code that way. So a lot of opportunity there, and as I said earlier, your 5 watts is really going to go a long way. So this can be a really fun journey. And that's all I have. Thanks for watching the presentation, and let me know if you have any questions.